There we go. Can you hear me? Wonderful. Okay. It's going to be a quite of a different energy now. So my name is Ólafur Waage, and I'm a professional keyboard typer. Who else is? Anybody else? Yeah, we go, everybody. So to start with, I am no Doom expert, and also I do not work for or represent the European Space Agency, which is also quite a way to start the talk. Okay. Some of you might know me from making silly videos on the internet. Some of you might also know me from making silly conference talks. Speaking of Rust, I love this talk. It took about a year of research to do, but it's not about Rust. So I think you'll enjoy it if you want to watch it. But today, I have one job, and one job only. I need to explain to you why this screenshot is really cool. Ready? Yeah, ready? There we go. Okay, let me just boot this up. Okay. Installing, and there we go, and Doom! There we go. So, Doom is a first-person shooter game released in 1993 and made by id Software. It's a game that at one point was installed on more machines than Windows. Yes, yes. Good clap from the audience. It was so much excitement about the release of the game that the developers were not able to connect to the FTP server to upload the server version of the game because all of the people who were waiting for them to upload the server version of the game. So, talking about the deployment and delivery, right? So, you're on Phobos, one of the moons of Mars. Come on now. There we go. It's the home of a teleportation experiment that went wrong. Yada, 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 monsters from hell. That's the story of the game. Good. Come on now. Are you not a friend of mine? There we go. So this is GitHub. In 1997, id Software open sourced Doom, and to put it mildly, the community went wild. I'm not a friend with this clicker here. The other one good? There we go. Here's an excerpt from the README file. Some project ideas. Port it to your favorite operating system. Quite a simple idea, and people did. This is a list of Doom ports, the wiki page for that. It's about 74,000 characters long. And to put that in perspective, it's the same article length as the Ubuntu Wikipedia article length. So you should step up your game, or the Doom ports will beat you. So yeah, people ported it to all sorts of crazy things. Here's it on a smartphone. Here's it on Sonic. Yeah, it actually doesn't play on the screen, but it actually does play the game itself. But now it has turned into more of a challenge. Can it run Doom, right? There's a Reddit, it runs Doom. Here's someone running it on a streaming deck. There's a homepage, Doom running on VLC, Doom in pure SQL, which is lovely. So, if you have ideas. So, you might ask, but why? Why is it so easily portable? It's relatively straightforward C with a few external dependencies that could be swapped out easily, right? So, here's an example of some code. It's not that this function is interesting in itself. This is checking if a monster is close enough to punch you in the face. But it is a good example of what most the source code looks like. It's like this. It's very unsurprising. In 2020, for those C++ heads in the audience, Jason Turner made a short YouTube video where he was playing with the idea of porting Doom to C++. And for those, that is not 11 minutes, that is 11 hours. He did not fully complete the project. It's out there if you want to play with it. Then in 2022, Patricia Oz had an idea of maybe Doom could be an interesting educational tool. So she continued where Jason left off and made a talk about all sorts of Doom problems. There's actually was a bug in the Doom allocator that she found, which was very interesting. This is where I was dragged into the picture because she knew of Doom, but she hadn't played Doom. So when refactoring Doom, the question became, it's a whole video game. So how can I make sure that whatever I refactored or changed to C++ is still okay? That's quite a lot, right? So Doom has an interesting feature where it allows you to record your play session. These are called demo files, and this is 1993. It's not like you could upload the thing to YouTube, right? That doesn't work. So how do you record a play session? Well, Doom, so instead of saving a video, Doom saves every single input that you just did, every button press, every mouse movement, etc. This can then be replayed by anybody else that owns a copy of the game. But how? But what about randomness, right? Doom has a table of totally random numbers which is then used by every single entity in the game. It's a single-threaded game, so everything runs in very specific order, which makes the game deterministic, which is very good. So going back to Patricia's question, how can I make sure whatever I change is still okay? Well, when you record a demo file, it can also write to an output file, which is like, I could write to a file how you did, how many kills, how many items, how many secrets. So this is how you did in that level. So you can use that data as a form of regression testing or approval testing. You collect a large set of strange and anomalous demo files, save them in a folder, run them with beautiful bash. Don't look at this is beautiful bash. And which gives you Doom on GitHub Actions. So here it's running, of course, on Ubuntu, and then all green. So whatever you changed is still okay, right? Wonderful. And since we're just checking the output against output, we don't need to actually play the game. We need to render graphics. It's all a state machine, right? So we can modify the game, run it as fast as we can, skip the drawing, and we can run multiple demo files. And this takes only a couple of milliseconds. So in that example, I had like 20, 30 demo files. It didn't even show up on the GitHub, like no seconds. So it was always 0 seconds, which was great. I gave a talk about this, Doom on GitHub Actions and other interesting things. And after I did that talk, and it was released on the internet, I got this message on Instagram. Hey man, I'm an engineer at the European Space Agency, and I've been meaning to run Doom on the OPSAT spacecraft. Maybe you'd be interested in partnering. My question was, wow, those spammers are really good now. Really targeting special niche interests now. But no, this is Social Press, not a scammer. Actually, very, very interesting guy. Spacecraft operations engineer at the European Space Agency, now a system engineer at Tanagra Space. And if you want in-orbit machine learning, he's your guy. So, what is this? OPSAT. A flying laboratory, ESA's OPSAT, is the first of its kind with the sole purpose of testing and validating new techniques in mission control and on-board satellite systems. Interesting. OPSAT is devoted to demonstrating drastically improved mission control capabilities that will arise when satellites can fly more powerful on-board computers. The satellite is only 30 centimeters high, but it contains an experimental computer 10 times more powerful than any current ESA spacecraft. It's about this size, if you've been traveling. So, not very big. The satellite has this idea of has never flown, will never fly, which is kind of a hurdle for a lot of innovation in this area. So the point was to break the curse. So because you've spent all these millions of dollars, you're not very receptive to, kind of experimentations. But the whole point of the project was to be experimental, was to do experimentations. So OPSAT was your flying laboratory to take down the barriers of spacecraft operations, to accept experimental ideas from the public. Good. So current satellites run a lot of specialized hardware, and for a good reason, because, space, a lot of radiation, a lot of unknowns. But here, they wanted to run as much off-the-shelf hardware as they could. To quote ESA, the platform consists of an Altera Cyclone 5 and an ARM dual-core Cortex-A9 M-core. So this was very off-the-shelf. There were some controlling units that were more like spacey, but the actual unit was off-the-shelf. Here we go. A part of the satellite where they performed the experiments ran Ubuntu 18.4. You might be thinking, 18.4? Well, it was the LTS version of the OS when we actually launched the system, we launched the mission. It's quite hard to do an upgrade in space. So when you make an LTS, this is what it means, right? So think about that, right? So this was a cool opportunity to get Doom to run on the satellite, but how on earth do I do that? Wait for laughter. No? Okay. No. So they had a Docker image that mirrored most of what they had running on the satellite itself. So the problem turned from how can I run Doom on a satellite versus how can I run Doom on a Docker, which is not as exciting, but hey, it's going to be running in space. So to start with, just mimic Doom on GitHub Actions, because that's how we got it to work initially. We picked Chocolate Doom 2.3 because of the libraries that were available in 18.4, that was the last one that could actually build Chocolate Doom. So again, I can also not apt-get install in space. It's kind of hard. So we would build the game and test on a test environment on Earth that mimics the satellite setup. And then we would pre-record a few demo files that the game would run. Good. We could check the output of the demo files in space versus the output of the demo files we got on Earth. So again, it's like the Doom or GitHub Actions. Do a diff if everything is okay. Because here's the thing. This is neat and a fun little project, but the satellite is being used for, actual science experiments, right? So the amount of time we got on the mission wasn't as much, right? So this kind of changes how we do decisions. We have to pick the tools, pick the path to follow, where we would know this is going to work, right? This is going to maximize our success. So that's, if you're thinking like, why did they do it this way? This is mostly why, right? So as an example, this is the diff of just getting Chocolate Doom to run. It's 31 files that changed, 370 lines, 130 deleted lines. That's it. Again, relatively simple C, not a lot of things you have to change, right? Like examples of things was like, oh, turn off the video driver because there's no screen. I can't, it's kind of hard with, maybe not a controller, keyboard, mouse, there we go. Kind of hard to see the satellite. We ran the game as fast as we can, so there's no, like, we didn't run at a 60 FPS, it just ran as fast as it could. And then some script files to run it and build it and do all sorts of fun things. We also created scripts to set up the project itself, and then when it runs, qapla', there we go, a couple of laughs. And then one fateful afternoon, just after Christmas, there we go. Ladies and gentlemen, we have obviously run Doom on Upsat. So this is super exciting. Yes. So for those who remember my wonderful bash script, it's an okay. There's no diff in the demos. So all the demos run the same as we expect them. Great, wonderful. We got a like from John Carmack, which was kind of fun. Yes, but I mean, this is cool, right? But getting an okay on a log line, come on, no. So technically, we ran Doom in space, but it has to be cooler than that, right? It's Doom in space. Can't end on an okay, right? So here's a little twist, though. We actually did have another experiment in mind, but it didn't work, which is the thing with experiments. Sometimes you have an idea, like, hey, maybe we can do this, but it doesn't work. Cosmic rays. In 2003, a Belgian voting error was detected because a candidate got 4,096 extra votes, which was deemed impossible. Possibly a bit flip that would be causing the error. Okay, and in 2013, a Super Mario player called Dora Teabag was playing the level when he went from this position to that position in one frame. There was a bounty on it, there was an idea, there was a thought that might have been a cosmic ray that flipped a bit on his console. It was later found out that his actual cartridge was not fully set in. So, but for a long time, like for a year or two, people were like, no, that's a cosmic ray incident. So yeah, can space radiation affect satellites? Yes, they can. That's why they have all this shielding and all these extra fun bits. So the initial experiment was, outside of just running Doom, was, can we detect bit flips on a satellite using Doom? Okay, so as I mentioned earlier, we can detect changes in the system by rerunning demo files and checking if the game ran correctly. So what we did was, what if we change the RNG table? We make it take way more space, we make it all 0, and make the character movements also depend on the random number generator table. Because it's all zeros, so we have this, and it's like way bigger. Here I have it as 65K. We actually tried like way huger RNG tables. What we would then do is every movement from the character would pull values from the random number table, which meant that if only one bit would flip in any way, the character would sway away, would move in another location, and then the game wouldn't work as correctly. We re-recorded the new demos, we did all the things, even took the mouse movements, so to get as many values as we could. I had one demo where I was just spinning around in a circle, just to use as many values as I could. So we made new demos with his chains. So if any bit would flip in the table, we should notice it, right? So here's a big green line. I love this big green line because this is about 8 gigabytes, which was the partition that we had on where Doom was installed. This picture is 1800 pixels wide, which means 4.44 megabytes per pixel. Some of you might be seeing where I'm going with this. Doom is 8 megabytes, which means that, so who has really good glasses? Doom takes that space on the disk. So this is why it didn't work. We were trying to detect a single event upset on a space that size on the hard drive. So we would have needed make the RNG table take way more space. But then it also have to travel through the whole table to then find the single event upset. So could the code achieve it? Yes, we would, like in simulations where we would mess with the memory. Yeah, we could detect it. But in space, no, it didn't work. But this was the actual plan for the project. So what do we do then? We have a project, it ran, we failed the first experiment, we need a second experiment. So what can we do? The satellite didn't have much time as well. It was launched in 2019, that's why 18.4. So this was the state of the perigee of the satellite when we actually ran it in space. So as you can see, something is happening. Something's going on. So the satellite didn't have much time left. Then George had a brilliant idea. The satellite has a camera. Ooh. What if we use the photos from the satellite to replace the sky in the game? So the idea was we would take a screenshot like this, we would run around the game, we would find a screenshot where we were looking at a lot of sky, and then we would insert Earth here, right? Find a good photo that the satellite would take. And what we wanted to do was when the satellite would take the photo, it would run Doom immediately afterwards, use the photo it just took. So it is the view of what the satellite is looking at. There's one slight problem. So this is a photo that OPSAT took. It's high resolution, it's great, it's beautiful color. And because the satellite has no graphics rendering hardware, or even graphics drivers that had nothing like that, we had to draw the game in software mode. So what do you mean software mode? Well, Doom has a predefined palette of colors it can use. So everything in the game is drawn using this set of colors, these 256 colors. Come on now. There we go. So it cannot, if you're running in software mode, it cannot use any other colors than this. There are probably cool, hacky ways to do the thing, but again, we had to use methods we knew would work, right? So you're trying to draw all of these beautiful colors with those colors. So that's probably going to work, right? I don't know, we try it out. So we can try on Earth, try out some demos. So we experiment a lot with the different photos and different file formats to see if we can get a photo that looks great in game. Well, first you can do is just a gradient. Let's see what happens when you use a gradient in the game. Oh, no, that's not good. Well, the next thing, that's one of the famous ones, like a TV test thing. It's also like skewed and off. The colors are, not great. You see the purple there, and then it's just blue. Because Doom does not have a lot of purple colors. Well, thankfully, there's not a lot of purple in Earth, so that's maybe helpful. What about this like little demo photo from NASA? Oh, that's not acceptable, right? That's not good enough. So how do we fix this? So here's an example. Look at this little gray patch here. That is this bit of the screen. And if you notice as well, the photo is flipped. That's a thing that Doom does as well. It flips the photo, which is also not very helpful. So the game has data stored in a file called doom.wad. And we're using the shareware version as well. There are tools called deotext that allow you to extract the thing. And here is sky1.bmp. And you can just swap out the file and then repack it. And now you have your doomearth.wad. So doing the swapping isn't the issue. Like you run the script that does this, that's not a problem. So yeah, this isn't good enough. The satellite is going to take gorgeous photos of Earth, so the photo should look great in game as well. So George has another suggestion. Another project he had been working on was related to taking photos using the satellite, because as you can imagine, the conditions in space aren't always great. So the work was to help with denoising, because sometimes photos look, off. The idea was to use machine learning techniques to denoise the photos. So the idea was to use k-means clustering to reduce the amount of colors of the image to 256, which then the game could then use. That's done like this. You take every pixel, you normalize it, you put it to an array. Come on now. And you call dkm k-means Lloyd on the pixels, and you get 256 pixels back. You can also do prediction on the nearest values to get the centroid, and you can denormalize on the colors. So for the nerdy ones. So here are two pictures. One is 30,000 colors, the other is 256. So can you? Oh, that's not me. That's the algorithm. So, but thank you. So who can detect which is which? Any suggestions? Yeah, that one. Okay, that one. Yeah. So this one is 37,000 colors. The other has 256 colors. Cool, right? So, yes, let's try it. Let's use that new great picture. So this is the old picture. So how does it look in game? Oh. No. Okay, it's better, right? It's an improvement, but it's still not good enough. The reason is the original problem is still here. The set of available colors is still not good enough. As we told, like the purple isn't there. And the little nuances in the grays and the blues, like Doom has like, I don't know, 10, 15 colors of blue. So that's not good enough. So yeah, we're using this little set. So the idea I had was, can we just change the color palette? Is that too much of a... Nobody's going to notice, right? Just play with it a little bit, right? Because the format isn't that tricky. It's just little hex values of each color. So, and also if you mess with it, you can get some fun outputs as well. So here's the game plan. Take a photo with the satellite. Come on. Resize the photo so it fits the sky texture. Resample the photo to 256 colors. Do magic. Replace the photo and the palette in the game. Play those demo files. Take screenshot at beautiful locations where we're looking at we have a lot of space. I mean, it's not very great when you're looking like indoors and there's nothing to look at. So we would pick some locations to take a screenshot on. And that would be it, right? So what is this magic, right? So we need to figure out what color, so we have a color in the original image, what color you are closest to in the Doom palette, right? And we save all of the ones that say that they're pretty far away from an original color. If you're pretty close to a blue one, you're good, you're fine. But if you're like, I'm like this purple, like you're going to be far away from everything else. That's not good enough. So we would save all of those, and then we would average those colors, right? So they're in a cluster. Like we have 5 colors that all say that they are closest to this blue here. So they are one family. We would average those colors out and replace the color in the palette with that average value. And this is done for every pixel in the photo. And then we also do it per run, because where we are looking at in the sky is also different. So if we're looking at some skies or clouds, the color palette is one way. If it's like some land, it's more green, etc. So the example is we have 3 greens here. They all say that this green over there is their closest one. We would average that one and replace that one with the color. So here's an example of one color palette. So this is original, and this is the changed one, right? Original, changed. So it's not that bad. It's like a slight shift. Some of them are pretty different, but yeah, it's fine. It's fine. It's fine. So we go from this to this. Improvement. Good. Sadly, it's still flipped, but whatever. That's fixed in the actual outputs. So on the 24th of March, 2024, we got this screenshot. What I would have to do was I would sit and watch an FTP server and hit refresh when someone would say, like, we have new photos, and try to find out, like, okay. Because it would take a bunch of runs and a bunch of photos. So the thing was, this is a photo. It's beautiful. We have some, maybe some glaciers, some mountains, some little rivers flowing. Some photos would look like this, because the thing also was the minutes that we had running the satellite wasn't like, okay, here's Iceland and here's a beautiful view of Iceland. We would just get whatever. So sometimes we would also get this, which is, blankness of space. Sometimes get this. This is also another beautiful one. Another thing I learned is that it doesn't tile, so the Earth doesn't tile very well. So Doom expects, the textures to loop around, but even though the Earth is circle, it doesn't loop around that way. So that has to happen. You might also notice if you look at the bottom, it's kind of green. If I go back, kind of less green. If I go back one more, a little bit blue now. So here you can see the actual palette changing with each image. Go back forwards here. So it is subtle. It's like very, very limited, but yeah. So another issue is that the satellite needs to point towards the Earth to take photos, because that's where the Earth is. Yes. And once it gets closer and closer to the Earth, pointing towards the Earth isn't exactly very healthy. So that's an example of like nadir pointing that the satellite would do. So you could say that playing Doom was aiding in the inevitable doom of the satellite itself. Yes. Then on the 22nd of May, 2024, sadly, it tumbled. RIP. So I live in Norway. One of the final passes it went over Oslo. So I tracked it, but apparently it's June, and even at 21:13, it's still bright out. So yeah, you can't see it, but it was there in my heart. It was there as I flew over. I don't remember exactly where it tumbled. I think it was like outside of South America, but yeah. But yeah, it was there in our hearts. There it went. So as I mentioned, the point of the OPSAT missions was to be a laboratory. And the second reason for running Doom on a satellite was this, the thing I'm doing right now. Because now you know about OPSAT, because there's another satellite. Ooh. So OPSAT Volt is launching in, let me go back, sorry, in 2026. So if you have ideas, if you're researchers, people online, hello online people, you can go to this website, OPSAT ESA int Volt. It hasn't launched yet. So if you have ideas for experiments, it is a different satellite, so I would research what are the capabilities. I think the point that optical and quantum communications. So if that's a thing that interests you, then do that. Tell them I sent you. I don't get paid for this. No. I would like to thank the people from ESA, everybody at the mission control team. Thank you very much. Because without them, no. I was just at my computer in Norway. I was not doing anything interesting. So yeah, Doom in space. Thank you very much.